Okay, so looking at the second derivative, what does the second derivative show? It shows us concavity. So what's happening is the second derivative is the change of slope. So what does the second derivative being positive mean? It means that the first derivative, the slope, is becoming more positive or increasing. So if I look at that, I can start with a negative slope here, sloping down. It doesn't have to be negative, but I'm just going to start with negative slope. It's going to become more positive, more positive, more positive, or in this case, less negative, less negative, less negative, which is same as more positive. And we end up with this curve. It's curving up. So we say that it's concave up. The opposite happens if the second derivative is negative. Second derivative negative means that the derivative is decreasing, or the slope is decreasing or becoming more negative. So if I start with positive slope, this becomes more negative or less positive. Less positive, more negative, more negative, more negative. We get this curvature, which we call concave down. So a negative second derivative indicates a concave down point. And where the second derivative is equal to 0, this is a potential change of positive to negative concavity, or an inflection point. Okay? Now we have to be careful because we cannot assume that second derivative equals 0 is an inflection point, but it's an indication that it could be, and we still have to check for concavity change. So if I take a look at this graph here, we can start picking out points here. Well, A represents the domain boundary, so as I approach A from the positive side, I get the y coordinate at A. B is going to be that coordinate there. So that is a maximum point. Okay, so what's happening here is that the f prime value at B, I'm going to write B, is equal to 0. We have a horizontal tangent. At B1, it's going to be that point there. Notice that's curving down and switching to curving down to curving up. Well, that's a point of inflection. So at F, we call, well, that's not necessarily F double prime equal to 0, although it can be. So we're just going to call B1 an inflection point. And potentially that could be where the second derivative is equal to 0, but we don't know for sure. C is a minimum, and it's where it's negative. Sorry, it's got 0 slope. So at f prime of C, we know it's equal to 0. And it happens to be a min. This point C1 is an inflection point again. Okay, it changes from concave up to concave down. D represents, again, a max. So f prime at D must be equal to 0. And then the last part here is kind of cut off, but as x goes to E from the negative side, or sorry, from the positive side, it's going to be equal to f of E. So that's going to be our domain boundary, and we can indicate it that way.